Hey everyone, Mr. Kaczynski here. Starting up a new section in IXL's Algebra 1 skills. Double E is over radical expressions. Simplifying radical expressions today. Helpful when we get an irrational answer and we want to leave it exact but simplify it. No decimals here. Alright, so when we have something like the square root of 18 and we want to simplify it, simplify means get rid of any perfect square factors in the radical. So I know 18 is divisible by 9. Okay, so I can rewrite this as the square root of 9 times 2 because that's still the square root of 18. And actually that's exactly equivalent to the square root of 9 times the square root of 2. And we all know that the square root of 9 is 3 because 3 times 3 is 9. And the square root of 2 is irrational, so we're just going to leave it as that. So this is called simplified because the number that's inside the radical, that 2 right there, doesn't have any perfect square factors, as opposed to 18 that wasn't simplified because it was divisible by a perfect square, 9. Let's do this a few times. Square root of 75. Now, you have to think to yourself, is 75 divisible by any perfect squares? Like 1 squared, or 2 squared, or 3 squared, or 4 squared, or 5 squared. Yeah, it's divisible by 5 squared. It's divisible by 25. 25 times 3 is equal to 75. So we can think of this as the square root of 25 times the square root of 3. The square root of 25 is 5. And the square root of 3 we'll just leave as the square root of 3. So, square root of 75 and 5 times the square root of 3 are equivalent to each other. One more and then we'll make it a little bit tougher here. So, 147, is it divisible by a perfect square? It is. Otherwise they wouldn't be telling us to simplify it. 49 times 3 is 147, and the square root of 49 is, well, I guess we'll keep breaking this up. So we can rewrite this like this. Product of those two square roots. The square root of 49 is 7, and the square root of 3 is irrational, so we'll just leave it as the square root of 3. So 7 times the square root of 3 is how we would simplify that expression. All right, so now we've got 10 times the square root of 245. All right, well, 245 is, again, divisible by a perfect square. And, again, it's 49. 49 times 5. And it might take you a few tries to figure out what perfect squares it's divisible by, okay? So, this is 10 times the square root of 49 times the square root of 5. And we know that the square root of 49 is 7. And we also know that 10 times 7 is 70. So 70 times the square root of 5 is equivalent to 10 times the square root of 245. And we call this simplified because that number inside the radical, the 5, doesn't have any perfect square factors. It doesn't have to be prime. It just has to be not divisible by any perfect squares like 4 and 9 and 16 and 25 and 36 and 49 and so on. Let's do this a couple more times. So 198, I know that that's divisible by 9. So this is the same as 9 times 22, which is equal to 2 times the square root of 9 times the square root of 22. 22 is divisible by 2 and 11, but neither one of those are perfect squares. So the square root of 9 is 3. And then we'll also do 2 times that 3, which is 6. So 6 times the square root of 22 is the simplified version of 2 times the square root of 198. And you can type them both into a calculator and you'll get the same decimal. All right, one more. This 363 is divisible by 121, which is a perfect square. 11 squared is 121. So I can make this into 9 times the square root of 121 times the square root of 3 The square root of 121 is 11. And 9 times 11 is 99. So 99 times the square root of 3 is the simplified version of that original radical expression, 9 times the square root of 363. All right, so that's the intro to simplifying radical expressions. Good luck. Let me know how it goes in the comments.